1 times 16. Does that add up to 8?
Yeah.
Dan? No. 1 plus 16 is not 8.
Oh, I thought you said there's 8. Oh, no. Okay.
Sorry. So just to be clear, it has to multiply to 16. Multiply to 16. Add up to 8. Okay, so it's a little bit guess a check here, but these are the possibilities. Do any of these work? Do any of these add up to 8? Like 1 plus 16, 2 plus 8?
Yeah.
Which one?
Like the ones that factor from 16.
Which of these add up to 8? These pairs, because 1 times 16
4
is
plus
16.
4.
Exactly. Okay. So now what you do next is you write x plus 4 in parentheses. That's the first one. And then you do x plus 4 in for the second one there.
Okay.
Okay. So whatever we find that works, we're going to put in parentheses here. Now, this one's kind of an exception. You now set these equal to 0, or this thing equal to 0. So you set both of these equal to 0.
Yeah.
Okay. And you solve by undoing whatever's there. So in this case, you're going to subtract 4 from both sides. And you're going to subtract 4 from both sides.
Okay.
All right. So what do you notice about these two numbers?
They're both the same.
They're the same. Okay. So this means it only has one x-intercept.
Yeah.
Okay. So if you factor and you get the same thing, it's only one intercept. All right, let's try so let me find another one in the sheet that's similar. All right, let's do number 9. 9's kind of the most similar to this one. Did you get all that down, or do you need me to scroll back up?
No, I got that all done.
Okay, fantastic. All right, so this is the same game. You want to find two numbers that multiply to 36, but add up to now -12. So it takes on the sign.
Yeah.
So let's go through 36. All right. Like 1 times 36, is that 36?
Yeah.
Okay, how about 2 times 18?
Yeah.
3 times 12?
Yeah.
4 times 9?
Yeah.
6 times 6?
Yeah.
Okay, now what do you notice about all of these when you add them up?
They all equal into 36. Or when you add them up.
Yeah, what do you notice about, like, what is 1 plus 36?
37.
Okay, and 2 plus 18?
20.
20. Now these are positive numbers, and what do we want over here to the left? What's in blue?
Negative.
Negative. So you might think, well, how do I do that? Well, you have to make both of these numbers negative, because a negative times a negative makes
A negative.
a positive.
Two
negatives make a positive.
Yeah.
But when you add it up now, you get a.
Wait, so you just add the negative, like just add it.
Well, let me ask you, does it work? Does -1 times -36 equal 36?
No.
Yes.
Wait,
I'm sorry, multiply.
-1 times -36?
Yes, two negatives.
Yeah.
Okay, but we want a negative number that it adds up to.
Yeah.
Okay, is this the first time you're seeing factoring?
Yeah.
Okay. We should do this differently then. Okay, let's not do
Well,
this.
we've done it for 2 days, but I was absent yesterday.
Okay.
Yeah.
All right, let's not just ignore this problem. Let's go back and do 6. This is a better one, and then I'll pull some problems out of my my practice worksheets. Okay, we want two numbers that multiply to 5, but add up to 4.
All right.
So what I suggest, and this is what I have students do, is you have to figure out, and you always start with 1. 1 times what number gets you to 5?
1 times what number gets you to 5? 5.
Yes, 5. Okay. And then you try 2, but 2 doesn't work. They have to be whole numbers. 3 doesn't work. 4 doesn't work. 5 works, but you already have it here.
Yeah.
Okay. So does this add up to 4?
Adding them?
Yeah, you have to add them now. Does this add up to?
No.
No. Okay, so this is considered, this is an exception here. All right, this is really bad. Let me go get my worksheet. That's going to help you learn this.
Okay. bet.
Because this is not good. Okay, new problem here for us to look at. X squared plus 7x plus 10. Okay, so again, you want to find two numbers that multiply to 10 and add to positive 7.
Okay.
So you always look at that last thing, whatever that is, and you're like, all right, I got to find two numbers that multiply to 10, but with the added constraint that they add up to 7.
Okay.
Okay, so let's write 10. Can you think of start with 1. 1 times what number gets you to
10.
10? 10. Okay. And if you want, you can add it right away. Get 11. You're like, that's not right.
Yeah.
How about 2? 2 times what number
5.
gets you 5? What is 2 plus 5?
7.
7. Does that work?
Yep,
Yes.
it does.
So it becomes x plus 2, x plus 5.
And then that's the answer, right? And then you can check it after.
Well, you don't want to foil to check. It takes too long. This worksheet that you sent over is like a synthesis of a couple of concepts. So I think we should just focus on factoring until you get better at it. And let's see how far we can go on that today. All right, so let me give you another problem here, a slightly more difficult one to think about here. Same game though, same game. You've got find two numbers that multiply to 44, but add up to 15.
Are these different problems?
I'm doing them off. I'm pulling up my own worksheet because the
Yeah,
one you've got
okay.
it's gonna confuse you if we keep doing
Yeah,
it.
that's fine. That's fine.
Because with two problems, you had exception, whatever. So two numbers that multiply to 44, but add up to 15.
Okay.
So again, you just start with 1 and 44.
They add up to 44
They have to add up to 15.
and then they multiply into 44.
Yes.
Okay.
Yes. And the reason you start with multiplication is because it's a more restrictive constraint, because there's a
Yeah.
lot of numbers that add up to 15, but you only have so many that multiply to the number. So then like 2 and 22.
Yeah, I'm doing that.
Right. And then, so this is where I usually ask students about their divisibility rules, and they always say, don't remember. Are you allowed to use a calculator?
I don't think so.
Okay. So 3 does not work.
So 3 and 12, right?
That's 36.
Oh yeah, yeah. Oh my gosh. Wait, don't you add them though? 3 plus 12 is
They have to
15.
multiply. You have to multiply first. That's the first constraint.
Oh yeah, you got to get it into 44. You're right.
Yeah, you got to multiply first. So you find that 3 doesn't work, but you find that 4 does.
Four times what? 12.
That's 48. It's too big.
11.
11.
Okay, so.
And 4 plus 11 is 15. So I like to circle the ones that work because there's a lot of numbers over here on the right. And then on the left here, you write your binomial pairs. So it's x plus 4, x plus 11.
Yep.
Okay, so here's another one to try. This one's a little easier. I'll have you, you try this here. So I'd like you to try this one on your own, please.
Okay. C2 plus 9C. So it has to multiply in 18 and add up to 9.
Yes.
Okay. 3 times 6.
Yeah, so 18 becomes 3 and 6.
So
Okay,
it's x plus 3 and then x plus 6.
perfect. Okay,
Okay.
now just keep in mind the variable here is actually c, so it's really supposed to be c plus 3,
Okay.
c plus 6, but that's because I'm doing something different than you.
All right.
All right.
Oh, yeah,
So
you're right. You're right.
so notice every single problem we did just now was what I call the plus plus case. See how there's two pluses, two pluses, two pluses, two pluses, right? And then the first one we did had two pluses. Do you see that?
Yeah.
Okay. The next case you want to learn is the one that I was starting to work on, and then I realized this is like the first time you've ever seen this. So we need backtrack a little bit. This is the minus plus case. Okay, so see how it goes minus and then a plus.
Mhm.
So you need two numbers that multiply to positive 10, but they have to now add up to a negative number, -7. So this is where you don't do 1 and 10, you do -1 and -10. They're both negative.
Yeah.
Okay, now these add up to -11. So you try -2 and -5. What does -2 add up to with -5?
-7.
-7, and that's what we want here. So now
Okay.
you go x minus 2, x minus 5.
Okay.
Please get this down in your notes or
All right.
really study it, because I'm going to give you one just like it now.
Okay, hold up.
Wherever you got it.
All right. I got down.
Okay, so it's a new problem here. X squared minus 4x plus 3. So what you have to start noticing with these problems is, oh, it's a minus plus. Minus plus means that they're both negative. Okay, so you look at 3, and normally it's just 1 times 3, right? But that doesn't add up to -4. It adds up to +4. So that's why you have to make them both negative.
Mhm.
Okay, so this becomes x minus 1, x minus 3.
Okay.
All right, you ready to try one on your own here?
Yeah.
Okay. All right, let's take a look at this one.
All right.
Two numbers that multiply to 27 but add up to -12.
Two numbers that add up to 27 but
Yeah.
multiply to -12.
No, I'm sorry. They multiply to 27. They always
Yeah.
multiply to the last one and add up to
Okay,
the
okay.
middle one.
Okay.
Always.
Can you scroll up to the other one? Like I got it down.
Of course.
Yeah. They multiply to 27, right? They
Yes,
multiply to 27,
yes,
right?
they multiply to 27. Yeah.
Okay. Is it x -3 and then x -9?
Yes. So we would say x minus 3, x minus 9.
Yeah.
All right, let me have you try one more before we move on to actually that you've already done that type. Let's go this one. And if you prefer, you can treat it as x instead of this new variable. You can tell it to me with x. But one more here, and then we'll jump back to see what else you got on your worksheet that we can tackle here in order.
You want me to do this one too?
Yes, yes. One more here.
This is like the same stuff I have on my worksheet though, right?
It is, but your worksheet has like 5 types on there, and
Yeah,
you'll
yeah.
you'll get very confused if I just start running through them. If you need us to go through the worksheet, we can.
No,
But
no,
it's
no, this isn't homework or anything.
okay.
It's just, yeah. Mm, shoot. I do not really know what goes into 63.
Okay. So that's something we'll have to work on here. But
Well,
so
I would deal fine like doing it like, but I would just have like a lot of time. Like I would think about
yeah,
it.
that's fine. That's fine. So it's -7 -9. So it becomes f -7, f -9. There's only that and the -1 and
If I was
-63.
on a test, I would like just do it like adding it or like just doing it like normally, but like I don't like kind of
Okay,
don't have a lot of time, so
so let's jump back to your worksheet here, and let's go back to number 9. Okay,
okay.
so we've talked about 2 cases. So case one is this minus plus. I'm sorry, it's plus plus. Case 2 is the minus plus. Okay, so this is a minus plus problem, and you have to identify that from the start. All right, so now you want 2 numbers that multiply to 36 but add up to -12.
Okay.
Okay, so like 1 and 36, 2 and 18. See, I'm going in an ordered list here.
Yeah.
And that's the way you want to try and do these. You want to say, all right, this is my list here.
Okay.
So do any of these add up to -12?
Adding them together?
Yeah, they all multiply to 36, but do they add to -12?
No.
No, they don't. Okay. But if we make them all negative, because we're supposed to in case 2,
They still don't, right?
well, take a
Wait,
look.
no, if you add them, yeah. It's the 6 and then
Yeah,
the
-6 and -6. So it becomes x minus 6, x minus 6.
yeah. So that's the final answer,
That's
right?
the final answer. Yeah. Okay.
Yeah.
Now let's look at number 10. Okay, number 10. And like we're going between these 2 cases here. I'm trying not to overwhelm you with, too much, but you have to recognize that, oh, this is a case 1. This is a case 1. Okay. It's plus plus.
Okay.
Okay. So case 1 is a plus plus. That means you're looking for 2 numbers that multiply to 100, but add up to +20.
Hmm.
Okay. but since it's positive, plus plus, they're both positive.
Okay.
So
Okay.
like 1 and 100, 2 and 50. Okay. Now you may find that you don't have to make this list. You can just see the right answer.
Yeah.
But making this list on the right here is probably the hardest part for most students. It's like, what are all the things that work out here?
Mm-hmm.
Do any of these add up to positive 20?
Yeah. The end 10 and 10.
10 and 10. So what is your answer here? What does this become?
X and X plus 10.
Okay,
X plus 10.
perfect. Yeah. Okay, so with the limited time that we have left here, we're going to work on, sorry, this didn't mean to do that. We're going to work on what are called difference of squares. Okay, so let me grab question number 2 here. We'll spend a little bit of time here doing difference of squares. Difference of squares. Okay. Now, do you notice that this only has 2 terms in it
Yeah.
and it's being subtracted?
Mm-hmm.
Okay, that's really important here. Okay. So let me show you something here. Do you see that 9 can be written as 3 squared?
Mm-hmm.
So now this is difference of squares. The difference literally means subtraction, and you have 2 squares. You got an x squared on the left, right? You got an x squared on the left and a 3 squared on the right. So here's the formula for difference of squares. A squared minus b squared becomes a minus b, a plus b. So you have to figure out in this problem here, what is a and what is b? And do you see that a is really x and b is really 3?
Yeah.
Okay, it's the thing that's being squared. Okay, so for you, you're going to write x minus 3 because a is x and b is 3, and then x plus 3.
Yeah.
Okay. So this is your answer. This is what we're working towards, but it's a different type of problem completely than the one that we just been doing. So I just want to spend a few minutes doing these. So let me give you another example of difference of squares. Okay. So let's say it's x squared minus let's go 16. Okay. So what you have to do is you have to figure out what are you squaring minus what are you squaring. Basically, it's like, what do you do to go back to the previous line? Like, what do you square? What do you square to get back to x squared? What squares gets you to x squared? The answer is x.
X. Okay.
Yeah, because when you square x, it becomes x squared. Now, it's nicer when it's a number. It's nicer when it's a number here, okay? So what squared gets you back to 16?
X. Wait, no. 2.
2 squared is 4. All right, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You have to know these. This list
Okay.
goes on and on. Okay. So what do you square to get back to 16?
4.
4.
2.
So 4 is what goes in parentheses. Now, do you see how this looks like a squared minus b squared? There's something in parentheses that you're squaring.
Yeah.
Okay, so what is the a in your problem?
The A in my problem.
Yes, what is representing a up here?
X.
X, that's right. And what is representing b?
4.
Okay. All right. So this formula, you have to know a minus b, a plus b.
Okay.
You have to know this. Like, you have to roll out of bed and know this formula.
Okay.
All right. So now let's go back to your problem here. X squared minus 4 squared, it becomes x minus 4 because a is x and b is 4, x plus 4. And the
Okay.
order does not matter.
All right.
The order does not matter. All right. So let's have you try one here. Let's go x squared minus 100. I want you to factor this for me, please.
All right. Can you go up on
Of
the?
course.
Up. I'm not gonna lie, this is like all over the place. Like I'm confused.
Okay, so what squared gets you back to 100?
Oh,
What squared gets you back to 100?
50?
50 squared is 2500. So squaring means you multiply it by itself.
10.
10, yeah. So this becomes x minus 10, x plus 10.
Okay.
All right, so we do have to stop here for tonight, Remy. Good job. These things go quick, so we'll have to maybe just pick less topics to try and cover next
Yeah.
time. But we're going to do Tuesday, Thursday next week at this time, and
Okay.
I'm looking forward to helping you. So thanks so much.
All right.
Have a
See
great
ya.
night. Bye now.
You too.